All right, we are continuing with section 6.3. Our focus today is on multiplying binomial expressions that involve radicals. Okay, we did a little bit of this yesterday. So take a minute and, actually we did this yesterday, didn't we? There we go. So we're still foiling, but how are these questions different from what we did yesterday? That's what I want you to be thinking about as we go through this. Okay, what's different about them? So if we were to FOIL this, first times first would give us 25. Outsides, okay. Insides, all right. And last, what happens when we take a negative root 7 times a positive root 7? It ends up being negative root 49, which turns into negative 7. Yes? Okay. So what happens to that middle stuff? And what was it about the original problem that would tell you that was going to happen? Okay. So we have two factors that are almost identical, except one's positive, one's negative, right? We call those conjugates. A plus B, A minus B. Whenever you FOIL conjugates, the middle stuff's going to drop out. So this is going to cancel out. We end up with 25 minus 7, which is 18. So we get a nice integer value. We don't have any radicals left. Okay? That's going to be important for the next type of question that we're going to look at. Okay? So go ahead at your tables and try this next one. All right, first gives us what? 36. Insides and outsides, are those going to cancel? Okay. Last, it would be minus the square root of 144, but that is 12, right? We're multiplying we're squaring a root 12, basically. We're canceling the square root. So we have 36 minus 12, which is 24. So again, we're getting a nice integer value. Okay. So the last thing we're going to look at is this idea of rationalizing again. You have done some rationalizing when the denominator and numerator were just single pieces. Okay? What we have here are two terms. They don't both have to have a square root in them. Shut the door. But as long as one has a square root, we have to do something about it. Okay? We have to rationalize it. We can't leave that in the denominator. And the way we do that is we multiply the numerator and denominator by the conjugate of the denominator. Okay? So, if I have in the denominator here the square root of 5 minus the square root of 2, what would the conjugate of that be? Okay? And then I have to multiply the numerator by the same thing? Okay, let's look at the denominator first. Will the insides and outsides drop out? Because we're multiplying conjugates together, right? So what do we get for the first part? What is root 5 times root 5? Okay, just a plain 5. What is negative root 2 times positive root 2? So the denominator is going to turn into just a 3. Okay? That's our whole goal. We need a denominator that doesn't have any square roots in it. Okay? Now, for the numerator, we have a single term here, this 3 root 2, and we're trying to multiply it to a binomial type expression, right, that has two pieces. So we're going to have to distribute. What do we get when we take 3 root 2 times root 5? 3 root 2 times root 5. We're multiplying all those, right? You can put together ones if they're in the same kind of root. So the root 2 times the root 5 can be combined and become root 10. Okay, so we're going to have 3 root 10. And then when we distribute it to this piece, what is 3 root 2 times root 2? times, not add. 3 root 2 times another root 2. Okay, we have 3 root 4, but the square root of 4 is 2, so 3 times 2 is 6. Okay, now, we said the denominator simplified to be a 3. Can we reduce this? Can we divide both of those numerator pieces by that 3 from the denominator? Okay, so 3 root 10 divided by 3 would just be 1 root 10. And 6 divided by 3 would be 2. So that would be my final answer. Okay? All right. What would we need to multiply by on the next one? Okay. All right. So in the numerator, we have to do some distributing. In the denominator, we have to do some foiling. All right. It doesn't matter which one you do first. Let's look at the numerator. 3 root 7 times root 3. What are we going to get? Root 7 times root 3 would be 7 times 3, guys. 21. So 2 root 21. Okay. Distributing to the next part. What is root 5 times root 7? Okay. So we're going to get 2 root 35. And for the denominator, foiling that out, remember the insides and outsides will drop out. What is root 3 times root 3? 3. Negative root 5 times positive root 5. All right, so denominator turns into a negative 2. Can we do some reducing? So what is 2 root 21 divided by negative 2? Negative 1 root 21. Okay, and then 2 root 35 divided by negative 2 would be negative 1 root 35. Do either of those have a perfect square factor in them that we could simplify out? Okay, then that's all we can do. All right, how is the last one different? There's a couple things that are different about it. Denominator only has 1 square root instead of 2. We can still find the conjugate though. What is the conjugate of 3 minus root 6? We'd need 3 plus root 6. Okay. The other thing that's different is the numerator has a variable. All right. So we are going to distribute. What's 4x times 3? All right. And then 4x times a root 6. Okay. Denominator, 3 times 3. 9. Negative root 6 times a positive root 6. All right. So 9 minus 6 reduces to 3. Does that help us at all? We could reduce the 12x with the 3. We can't do a whole lot with the 4x root 6. 4 doesn't divide by 3. So I would take either answer. If you want to simplify it, the 12x divided by 3 would be 4x. And then we're going to have 4/3 x root 6 for the second part. Okay? But I would also take 12x plus 4x root 6 all divided by 3. That's fine too. If both things can be reduced, we usually reduce it. If only one can be, then that's your choice. Okay? So, can we FOIL conjugates? Okay? Can we use conjugates to help us rationalize these messy fractions? Yes? Okay. So, your assignment today You are working on day 2 of 6.3. Remember, we are getting ready for a test. Our next 2 days will be review days.